Hello.
Hey, Alex.
Afternoon.
Hey, Chris. We should have the Open Gemini
Yeah,
vote.
so I pinned him. I hope they don't get the time wrong because the daylight saving just changed in US, right? So is this time
Oh,
different now, Alex, for you?
yeah. We're we're there's 1 hour less between the US and the UK at the moment.
Yeah, he was actually just pinning me yesterday. Uh,
Where's he based? Are they based in the
he's
UK?
in China. No,
Ah,
He's in, yeah. So I just pinned him on Slack. So I'm hoping that he don't get the time wrong. Hmm. Yeah, he was just asking me yesterday whether he should send the slides. So I said, well, you can send it before or after the meeting. If you're not ready, you can send it after. So he said he will send after. Um, Maybe he think it's 1 hour later.
I'll be sad. I was looking forward to this. Hey, Tom, are you going to be in Paris next week?
No, uh, I would like to, but it didn't work out.
Oh, that's a shame.
I know. I was looking forward to it, but no, couldn't make it work. So you're going to have a good bottle of wine for me, okay?
I'll do my best.
Tom, where are you based? I thought you're on the West Coast.
I'm in Minneapolis.
Right. Minneapolis. Okay. Okay. So do we have anyone from what is this? Open Jimmy? Looks like not yet. Yeah, you might got the time wrong.
Yeah,
So
sounds like it. Are they on Slack? Or are
yeah,
they
that's the only way. Yeah, he was pinging me on Slack. That's the only way for me to communicate with him. I don't have another way to ping him. So um uh, I just
Gotcha.
pinged him, but it's not responding.
I guess the problem is it's like 11 p.m. over there, right?
Yeah, it's actually late over there. So
Well, if they're not available, we might have to postpone it to after KubeCon, I guess.
yeah. So maybe just wait for a couple more minutes and then if they did not show up, then yeah, we just postpone it. It's I know it's confusing, especially now. The bit at the same time just happened.
What is, I'm not sure Raphael will be ready to maybe present his the DR stuff.
Oh, Raphael, I'm not sure. I thought Raphael was talking about after KubeCon as well, so I'm not sure if you're ready to. If they don't show up, are you ready to present yours today? Or do you want to do it after?
But give me 5 minutes. I can be ready. Let me see. I just don't remember exactly which deck I wanted to present.
Are you okay? Yeah, I know that you said you want to present. Are you going to present this new document or the existing one? I actually forgot what what did
No,
we
the idea
do on last time?
no, I'm still working on the
The new one. Okay, so it's basically the existing one. Okay, yeah, yeah.
It was
then,
to present a deck, really, not the document itself, right?
Mhm,
It was
mhm.
some
Okay,
ideas.
so you already have a deck basically from your previous.
Right, several
All right.
decks. Let me see which one is the most appropriate here. Okay, so if it's fine for the team, I have a deck that is a little bit leaning towards OpenShift, but it still has the main concept that I wanted to share. Otherwise, I would have to prepare one that is neutral, vendor neutral. It's up to you.
I think we can live with OpenShift.
All right.
Yeah, I agree. Yeah, OpenShift and more specific use cases are better. Yeah.
Yeah, I know this is okay.
But
So
you can share your deck afterwards with us. You can make some changes.
yeah, I can. This is a
Okay.
public.
Yeah. Maybe later.
place.
Not right now. Yeah. Okay. All right.
Yeah.
Let me change the our agenda. Yeah. Please go ahead. You can. Yeah. Then
I'm gonna share.
go ahead and share it.
Okay. So this is how I approach the conversation with customers that want to talk about disaster recovery when using Kubernetes. Let's say, okay, I will replace OpenShift with Kubernetes. Okay, this is the kind of this is our I would recommend we have this conversation. Okay, the first thing I tell them is we don't try to recover clusters. We just worry about the applications that run in the clusters. So it's really about the business continuity of the services that this application provide. Many customers are fixated on.
Excuse me. I just got a response from this guy. Do we? Do you want to ask him to
He's
join
coming?
now,
Okay.
or do we want to?
No. If he's coming, by all means, I can do this another time. I can do this anytime.
Oh,
So should I stop
thank
sharing?
Thank you, Raphael, for being so flexible.
Yeah, no problem.
Okay, let me see. Yeah, he thought it's 1 hour later. So.
Hello? Can you hear me?
Hey, yes, we can.
Yeah. Okay. Hello everyone. My name is Xiang. Today's presentation will be presented by Shiran, and he can explain it more clearly than me. Okay.
Well, please share your slides. We couldn't see anything right now.
Okay.
Okay, wait a minute.
Also, welcome and thank you for doing a presentation at this time in your evening, which is quite late. Just to let you know, we're recording this this session so we can share it.
Okay. Yeah. Shall we start now?
Go for it.
Okay. Hello, everyone. My name is Shiran, and I'm from the Huawei Cloud Database Innovation Library. Today, I'm so excited to introduce something about the open source project named OpenGemini to you. So I'm the architecture of this project, and I want to push it into the CNCF sandbox. So I will start the presentation. Okay, the first slide, I will show you something about the observability data and the time series database. So time series database are used in various applications such as monitoring, IoT, and finance. They're used to store and analyze data from sensors, IoT devices, and the monitoring system. And it's providing insights into the trends or the patterns and the anomalies in the data. Some popular time series database include InfluxDB, TimesScareDB, or the TD Engine. And then the observability is a term used to describe the ability to monitor and understand the internal state of the behavior of the system based on its external outputs. It involves collecting, analyzing, and acting on data from various sources to gain insights into the health and or the performance and behavior of our system. And in this slide, you can see there are three types of telemetry data. All of them have the time step tag, so they are all the time series data. Unfortunately, most of the time series database I have mentioned above focus on the metric data storage and analysis. For log and the tracing data, we can just use some general build database or story engines such as Elasticsearch or ClickHouse. Yeah, so in this slide, I will show you some background and motivation of our project. You can see this picture is about the common architecture of a cloud-native monitoring system. The telemetry data is generated from various data sources such as container, from Kubernetes, and any other applications. It's collected by some agents and trans to the pre-computing layer to do some pre-aggregation by Flink or Spark. At last, it will be stored in various database. So you can see the database have different prohibitions. For example, the InfluxDB is fitting for metric storage and analyze, and Elasticsearch is fitting for log storage and some text searching, and the ClickHouse is fitting for tracing storage and query. For the multi-database architecture, there are many challenges for massive observability data storage. First is about the performance. So because the storage engine or the database are not purpose-built for the monitoring or observability scenario. So they lack of some of the monitoring operators such as histogram or the hot winter algorithm. So when we want to do some monitor analysis, we must pull the data out of the database or the storage engine, and they cause massive data transmission over the network. And the second, because of the multi-database architecture, the data will be redundant, stored in the different database. So the cost of the storage may be so high. And the last, the complex architecture lead to the high cost for operation and management. And so the OpenGemini community is aimed to build one database for telemetry data storage and analysis. For the performance, we build special operators such as histogram and special purpose-built index for telemetry data, schema, and query scenario. For the cost, we used the near data processing strategy to reduce the CPU and network cost. For the ecosystem, we support multi-protocols such as OpenTelemetry, Prometheus, and InfluxDB. Okay. And in this slide, I will show you some design of the OpenGemini. First, OpenGemini is a MPP database with a scalable ability. All of its components can scan out or scan in independently. And for its architecture, there are 3 layers. First is the interface layer. We support OpenTelemetry, Prometheus, and InfluxDB, and the standard circle. In the query engine, we purpose-built the different ecosystem operators, such as for log, for time series, and some circle plus pipeline pattern. And the next is general operators and executing framework for the query, for generating the query plan and executing the query. The last is the storage engine. We compose different index and the different layout for the different data types, such as metrics and the tracing, use the column storage engine. And the log storage use the raw storage engine. And we support different storage mediums such as HDFS, object storage, and the file system.
So
okay,
is this typically run within an operator in a Kubernetes cluster, for example, or do you run those different components on bare metal, or what is the normal topology?
First, it can run on the Kubernetes. We have some script for the cluster deploying and the runtime. So the first answer is we can run it on by the Kubernetes. And without Kubernetes, we can run independently with the cluster model.
Okay, thank you.
Yeah.
Yeah. We have a project named OpenGemini Operator. Yeah, it's especially for running OpenGemini in Kubernetes. Yeah, that's all.
Yeah, I will continue. And then and the next two slides, I will show some the evolution of the our OpenGemini time series database. When it comes as a metric storage engine, we compare it to the time series database such as InfluxDB and Data Engine. The OpenGemini get better read-write performance and the data conversion. You can see the first table when it compared to InfluxDB, OpenGemini queries performance get 2 to about 10 times better than InfluxDB. And when it compares to the data engine, and it will get about 1 to 16 times better than data engine. And we have the better write performance and less disk usage. It's tested by the TSBS benchmark, which is a time series standard benchmark. Okay, when OpenGemini as a log storage, we have the evaluation compared with Elasticsearch, which is popular task search engine. We get OpenGemini consume less memory to build for text index and takes less time to build the index and provide better query searching performance. The first slide is the query test about the index performance, and the next row is about the end-to-end performance of the query engine. So and the index size are less than the index search, and the build time is also less than it. This work we have published a paper to this year's SIGMOD. If you are curious about it, you can check it. Okay. And the next slide, I will show some information about OpenGemini and the cognitive ecosystem. As we know, the systems project has such as OpenTelemetry or the Kubernetes, and Prometheus have many requests for the time series database. I show you the three picture about how we compete with this software. The first is OpenGemini helps Kubernetes match edge device data. And the middle is OpenGemini can be used as a backend storage of OpenTelemetry. And last is OpenGemini can be used as backend storage of Prometheus by the remote write, remote read interface. Okay, in this slide, I will show you some use case of OpenGemini. OpenGemini is widely used in Huawei Cloud, and you can check it quickly. So actually, there are about 16 adopters use OpenGemini. Okay. This slide shows some information about the OpenGemini community. There are 23 repositories and 900 GitHub stars, and we have 45, maybe 46 contributors from different countries and the different university. And we have 5 maintainers, and our license is Apache 2.
Is your plan to
Okay.
Is your plan to submit OpenGemini to be a sandbox or an incubation project for the CNCF now?
Yeah, exactly.
That is fantastic news. Thank you.
Thank you. And last is the roadmap of the OpenGemini this year and the next year. So you can check it.
Is there out of the maintainers or contributors, is anybody building a commercial version or a supported version of this as well, or is this purely open source at this point?
Sorry?
So
Sorry, I can.
okay, sorry, let me rephrase the question. I was just asking if any of the maintainers or the contributors today are creating a commercial version of the project, or is the project entirely open source and just used by the contributors today?
I think it's not commercial. Some just like the some students we have connected in the social network, so they have the interesting about the project, so they will be a contributor into the project. So that's not commercial.
Right. Okay. Thank you.
Okay. So that's all. That's all my presentation. So if you have any other questions.
Can you show the adopters? I'm sorry.
No, go on, Jing.
Oh, just wondering. I think they have a page shows the adopters, right? You go back to that page. I mean, they are using this in production. Is that right?
This slide?
Yeah, they're using this project in production. Or what is okay? Adopt to type. Okay, basically they are using this in production. Is that what this means? This project, this adopters, they are using this project in production? Or is it like testing? Or I guess this the question is, at what stage are they using this project?
Okay, maybe Shanri, you can answer the question. I think some is for production, some are testing. The adapter here list or in their production.
The list adapter, they are all used in their business service. Yeah. They are they have tested some months ago earning. Yes.
Sounds good. I did have a question. You provided some comparison for InfluxDB, for example,
Yeah.
and I was wondering how you think of OpenGemini when comparing to maybe something like, a Prometheus server or a Thanos server today. Do you kind of see some overlap, or do you sort of see OpenGemini as providing the same sort of performance benefits for something like Thanos today? Or maybe put another way, are you familiar with the Thanos project? Do you know? The
Pandas?
Yeah,
Pandas?
that's right.
And I know it's maybe a query engine. I'm not very sure. So
Okay. I'll put the link in there.
Okay, I will check it.
I'd be
Sanos. Oh, okay, Sanos.
yeah. So I'd be
Yeah. So I get it. Okay. So in my mind, Sanos is a backend of the promisers. Okay, and it's managing the store the backend of the metric data and for some long-term storage and for the analysis. So, but compared to OpenGemini, we want to be a unified database for all of the elementary data, such as log and the tracing data and the metrics data. So we want to be more, we want to support more times time data types and more the query operators, which is purpose-built for the observability and IoT or some other scenarios for the time series data. So that's our end. In my mind, the Sanos is just for the metric data.
I understand. Okay, that makes sense.
Yeah.
I had another question around your storage engine. And I wonder if you could maybe share some more details of how you store the data and maybe like how you shard the data between different systems maybe.
Okay. In our system, first I will show something about the sharding. We have two layers of the data sharding. First layer is about sharding the data by the shard key. Shard key maybe is a time series key, or some some customer can define it. And the next we will sharding the data by the time step. So that makes the continuous a range of time data will be stored in will store yearly. So when we do some analyze about the times, the time range of data, we can have low times of I/O. So that will be efficient. And when next, I want to talk about something about the index. We have the invert index for the some series, just like one time series query, or the that's efficient for the for locating the data by some tags or by some tags. So when we have there are high cardinality scenario about the time series data, such as network. We have different source IP and des IP. There's a tag may be very the tag cardinality may be very high, maybe 1 to 1 trillion. So as this scenario, we can't use the invert index so because of the inverted list may be not efficient as this scenario. So we use column storage to store the data in a time range and use some skipping index to hint what's a max and mean data of this range, and for some overlap analysis. And for data layout, we will there are some strategy for different data. For data, we use append strategy to reduce the compaction or the sorting costs. For the matrix data, we use compose the data by the shard key or by the time series key to improve the performance. So, is that clear?
That is really helpful. Thank you. I see
Okay.
Raffaele has a question.
Okay.
Yeah, I wanted to ask if this the data is I mean, this database can be used for long storage of the data, or just a short storage, because and I'm thinking about the Prometheus and Thanos model, right? Prometheus is usually the short storage for metrics, and then the data, because it has to be very fast and very short sampling time, right? Very high frequency sampling. And then you can move the data to a long-term storage, which is usually Thanos, or there are others, right?
Exactly. We do the same thing. We do the same thing.
Right. So what do you see? Like, where does your product fit? Right? Is it short? Is it long? Is it both?
We have tighter storage for the times data. So for the nearest data, we keep them in the memory, such as DRAM or other media. And for the some warm data, we put it on the SSD. And for such as history data, we will keep it to the object storage for
Okay.
the low cost. Okay.
Okay. So you have
And
policy.
different type has different layout. Okay. Sorry.
Yeah, I see. So and then you have some policy or some intelligence that decides when to move the data to the lower
Yeah.
performing storage. Okay, got it. And I want to ask you,
Yeah.
when
Exactly.
you when there is metrics, usually there is also a need to generate alerts. So I wanted to ask you what
Yeah.
like if you're trying to solve that problem, what architecture do you have there?
We have two strategy for the alarm. First, when the computation may be before the data ingesting into the database system, and we have a pre-aggregation engine for the to the alarm to generate the alarm when it upper the threshold. So and for the and we have post aggregation stage for some not very emergent queries. So you can customer can use the two stage to generate the alarm.
Okay. And
As we know, when the data gets into the database, the query may be not such efficient for some emergency alarm scenario. Okay.
And are you
Okay.
is your alert like, I guess there is an expression language to define the alert and the threshold, right? But is it just on metrics, or can I do also log, or can I also alert on logs, for example?
Right now we just the alarm is just for metrics. For log, we supply we don't do some alarm business. Yeah.
Okay, all right, fair enough. Thank you. Oh, I have one more question. This there's a long discussion in the upstream between Jaeger and Prometheus, between the Jaeger and Prometheus community, to find a way to correlate metrics with traces. I guess if you have the two pieces of information in the same database, that must be easier, right? Can you guys do that?
Yeah, this is on our roadmap. So, the metrics and the trace, we can correlate them with maybe the trace ID, the same trace ID or the span ID. So we can, if we store them in a same engine, so we can do some just like join them by the span ID. So we will do some correlation analysis. So this is on our roadmap.
Okay, thank you. I don't have any more questions. It's really cool. I like this.
Thank you.
Whoops, I was talking on mute. I was saying this is really fantastic. Thank you for presenting this, and I look forward to reading the slides and finding out a little more later on as well. So thank you.
Thank you. Thank you.
Thank you.
So I will stop the sharing.
So when are you guys planning to apply for Sandbox?
Wait, I have a supply apply, or I have a submit or apply in the GitHub sandbox.
Oh, you have already submitted. Okay, can you provide the link?
Yeah.
Okay.
Yes.
That sounds good. Maybe Shing, one of us, should probably add a comment in there to say that they presented and a link to the recording.
Yeah. Okay.
Did we have any other agenda items today?
I just had an update from the NVIDIA on AI Store. I think last meeting I was asked to see if they wanted to present their big conference. GTC is consuming all their cycles right now, so they don't have the time to support presentation. Is their feedback.
Okay.
Oh, okay.
Thanks.
Maybe we can do that later.
Yeah. Well, I'll see if there's a time after GTC settles, if they want to, or maybe even I was reaching out to the CTO office. I could also reach out to the developers. I don't know them personally, but I could try to cold call them and see if they wanted to talk about their project.
Sounds good. Oh, and Tom, I know I'm on the hook to finish off the last couple of tidy ups in the performance white paper. I was planning on doing them this Friday. I'll ping you a note when I'm done. If you could give it one last sanity check, maybe we can have it ready before KubeCon.
Sure. I'll look for your email.
Cool. Thank you. Okay then, if there are no other items, I guess we get a few minutes back. Thank you everyone for joining our call, and thank you to the OpenGemini project team for a fantastic presentation.
Yes, thank you.
Thank you very much.
Thank you,
Thank you.
everyone.
Thank you very much.
Thank you very much.
Okay, bye-bye.
Bye.
张老师，是不是张老师？威廉张老师在不在？这个不张，这个是不是张老师？
我这样，他在录音
在的。
啊，还在不在录音？
哦，
我是刚才
你还没
刚
睡觉？
上来的。
你刚上来是吧？
我操，
他妈提前了。
我是12:25，11:25那个啥，微信的链接连不上来，输了半天密码。行，挺好吧？
带着技术移动问，对吧？
行，好，我早点睡觉。还
你
还好。
明天啥时候走啊？
我早上8点半的飞机。
那你快点。